Hope you are there.
Yes, sir.
Good. Now, pay attention. When we are talking about normal distribution, majorly we are paying attention, close attention to this curve. We are paying close attention to this curve. Yeah, we are paying close attention to this curve. You see, this is what we call a standard normal distribution curve. You see, a normal distribution, are we together? It is a symmetrical bell-shaped curve, as you can see it here. This is a symmetrical what? It's a symmetrical bell-shaped curve. Like you can see the shape here like this now. It is symmetrical because what we have here is the same thing as what we have here. Are we together?
All right.
Yeah, it's a symmetrical bell-shaped curve. It's the shape of a bell, as you can see it here. Where the area, the total area under this curve is equal to 1 or 100%. Are we together? That is the total area is equal to what? 1 or 100%. Are we together? Which means that the area of one part is 0.5. The area of the other part is also 0.5. Are we together?
Yes.
Good. Now pay attention. You see now, there's one thing more to look at. We call that Z distribution. What do we call it?
Z
distribution. Now pay attention. This is a normal distribution in general. Now there's a special type of normal distribution curve called the Z distribution. Now the Z distribution is a special type of normal distribution that has a mean of 0. That is, the mean is equal to 0, and the standard deviation sigma is equal to what? Is equal to 1. Now, a special type of normal distribution that has a mean of 0 and standard deviation of 1 is what we call the Z distribution. All together?
Yes.
Now, pay attention. One thing you really need to know again when you are solving question on normal distribution is that you should know how to convert a score into the standard form. If I give you any score X, how can you convert any score X to a standard normal score? All together? That is, you want to look at the formula for transforming. Let me say, look at it too. If you have a score X and you want to transform it to a standard normal score. That is, they just give you any random score X and you want to transform it to a normal score Z. How do you do that? We use this formula. Z, let me put it down in our color. Z is equal to X minus mu all over sigma. Which means X minus what? Minus the mean over standard deviation. This is how we convert from score X to a standard score, because whatever, pay attention, any score they give you, you must transform it to the standard score. Don't forget, whatever score they give you, you must transform it to the standard score. Are we together?
Yes.
Good. Exactly. So that's how we do it. Okay. Let us now look at, let me give you one example. For example, check it. Let's say now, let me give you one small example. Let's assume that they give you the mean to be equal to 4.0, and then I'll give you the standard deviation to be equal to 0.3. And let me now say your X like this now is equal to, let me say 4.4. How do you do it? How do you convert the score? Now let's convert. How can I transform this score X to the standard normal score Z? How can I do that? Oh yeah, what do we do? Z equal to what? X minus mean over standard deviation. So I have what? 4.4 minus 4.0 all over what? 0.3. And what would that give you? That will give you 1.33. Have you now?
Yes.
Exactly, 1.33. So that's what we do. All right, so that's Z. Don't worry. So now let us now solve a question. Now pay attention. Majority of what you are going to be studying under this normal distribution is that they'll be telling you to be finding probability. And another word for probability is that what is area. For example, now Z equal to 1.33. It corresponds to what area on the standard normal distribution curve. That's what you want to learn. And let us look at the question. Do you have any questions so far?
No.
Yeah, keep this one somewhere.
I've never.
What is it?
I said I've never put this course because we just started class.
Okay.
Never had a class.
Yeah, I understand. Yeah, let us now pick a question. I'm coming. Let us pick one question and solve. I'm coming. Let me see if I have a question. Okay, I've seen a question outside. Okay. Okay, let us solve this question. This simple question. Look at this simple question first. Before we start solving like a word problem. Now check. Assuming I have the mean to be, I'll give this same parameter 4.0, the standard deviation to be 0.3. Look at these two values. They're not telling you that you should find the probability, check, of this score X greater than 4.4. How do we solve for this? Remember, see, that probability is like you want to find the area under this curve. Now pay attention. Remember, first thing is to standardize this curve that you have here. Standardize it. Are we together?
Yes, yes.
That means it says Z equal to what? X minus mu over standard deviation. And that's equal to what? What's my X? 4.4 minus mu 4.0. Yeah, all over what? 0.3. If you do this, you have a 1.33. Good. Now pay attention. It is 1.33. Now, how do we get the area that corresponds to this 1.3? It means that C. It means that if I say probability of X greater than 4.4, you see, I have standardized X to be Z now. So I'll not be saying Z greater than 4.4. After we standardize 4.4, what did we get?
1.2.
What do we get?
1.33.
Exactly 1.33. Now, the first step is that standardize your X to Z. Then instead of God now saying this, we can now say this. Yeah. But yeah, now how do we look for this in our standard normal distribution table? Now pay attention. Remember, we have this curve here like this. Check. We have this curve here like this. Now we have something like, okay, 1.33. Now check. This is very important. You see, pay attention to this example. Now, you see the type of curve, the type of table that we are using. Let me tell you. The type of Z distribution table that we are using. Pay attention. The type that we are making use of. It is the one with, let me show you. Let's go to Z table. Hey, look at it. It is the one with left hand side shaded. Hello, are we together? Pay attention.
Yes.
Whatever you are finding, whatever value you are getting here, note that it is the area to the left part. That is the area to the left part, which means that what this thing will be giving you is less than. Hello. If you check, the area you are going to be getting is to the left hand. So you can see that it is the left hand side that is shaded here. Do you get that?
Yes.
So whatever area that you are getting here, whatever probability that you are getting here, automatically is for less than and not greater than. But assuming you are using another statistical table where the right hand side is being shaded instead of the left hand part, it means that whatever you are getting is greater than and not less than. Are we together?
Yes.
Good. Now pay attention. For this part, for this table here now, we are getting the area under the standard normal distribution curve to the left, which is less than. And what we are solving here, we need something to the right and not to the left. So how do we do it? Now pay attention that probability of Z greater than 1.3 is saying now 1 minus probability of Z less than 1.33. Are we together?
Yes.
Exactly. So what we need is greater than, and on the table we can get less than. So know this relationship, that this is equals to 1 minus P Z less than 1.33. Oh yeah, now let us do for Z 1.33. Now pay attention. Let's look for Z 1.33. Now check. This 1.3. Have you now?
Yes. Yes.
Good. I'm coming. This is 1.33. Now look at it to 0.33, and that'll give you 1.33. Do you get that? 1.3 under 0.03. What did you get? You get something like this value. What did you get? This value.
0.9082.
Exactly, 0.9082. Exactly. 0.9082. So what we have here is what? 1 minus 0.9082. And what's my final answer? What do we get here? Minus it. What do we have? 0.0918. That's what you have. How together?
Yes.
Exactly. And that's it. So it means that what you are getting now, check 1.33. So this area you are getting now, from here like this now, remember what we are getting is greater than, so from here like this now has area of 0.0918. Yeah. So as simple as that. There's a way you can get this value, this calculator, other than using statistical table. Do you know that? Are you a calculator?
Yes, yes.
Yeah. Casually?
Yes, casually.
Yeah, right. Put your calculator in start. Can you put it in start?
Yes, I've seen it start.
Yeah. Have you put it in start? It has shown start to your calculator.
Yes.
Good. I'm coming, please. Wait, hold on. Give me some seconds. So what we are trying to get is, we are trying to get, I'm coming. Probability Z greater than 1.33. Next. I'm coming. Hold on. Give me some seconds. Okay. You have put your calculator in start, right?
Yes.
Okay, now the next thing is that now check. You see now, press mode. Are you there?
Yes.
No. You have put in start already. Next thing, press shift.
Yes.
Are you there? Oh, yeah. Now press 1, which is start. Are you there?
Okay.
Hello, are you there?
Yes, I'm listening.
Now, the next thing is that now press distribution, this 5. Distribution, press it.
So I think we're using the correct calculator. We are missing that white calculator.
Okay, is that what you are using? Yeah. Don't worry, I'm not putting it to you see it. Now, the next thing is that, wait, let me start from the beginning. Then I'll send to you that you can just use it to make your own. You understand?
Yes.
I'm coming. Wait, I'm coming. Let me record it now. Pay attention. I'm coming. So the next thing is that, firstly, put your calculator in start. Using start, the next thing you are going to do is this. Press shift. No, yeah, press shift. Then you press 1. This part, you press 1. It will bring different type of data. So you are going to pick 5 distribution. Then you pick 1 probability. Now remember, we want to get for Z greater than 1.33. So you now press 1.33. So you get 0.9082. And remember, that is for Z less than 1.33. And exactly, that's what we go here. And when we use statistical table, that's what we go here. Did you see it?
Yes.
Exactly. So then you now minus whatever you get. You now say 1 minus your answer, then you get this final answer. That's it. You see that? Exactly. Yeah. You can use that later. I'll send it to you. Yeah. Okay, so that's for that. So let us solve real-time question. I'm coming. Let us solve real-time question. So, example. Okay. They said that Actually, I've solved this first one. This first one was like a question, actually. Okay, let us solve this question. They said, assuming a normal distribution, find A, the probability of a score. Look at this score now. Given population mean to be equal to 0, and variance to be equal to 1. So that's what we have, and variance to be equal to what? 1. Now check, how do we solve this question? Solution C. Remember that for this part, you were only giving something like 1. This like s greater than 4.4, right?
Yes.
So how do you now get for minus 3 less than x less than 1? It's very simple. Standardize this course first. Firstly, standardize. Don't forget, my mean is equal to 0. This is variance. And don't forget that our standard deviation is square root of variance. That's square root of 1, and that's equals to 1. Do you see that?
Yes.
Next, what do we now do? We now say, okay, we standardize the score. So when x equal to minus 3, what do we have? Don't forget, z equal mu. What's the formula? Do you remember? Tell me the formula. What's the formula?
X minus mu over standard deviation.
And that's minus 3 minus 0 over 1. And that's minus 3. Also, if I standardize this one also, I have what? Z equal x minus mu over standard deviation. And that's minus 1 minus 0 over 1. And that's minus 1. Remember that you are asked to find the probability of minus 3 less than x less than minus 1. This is the same thing as probability, because when we standardize, we still got the same answer. Minus 3 less than z less than minus 1. Now, what you have here, what you have here is equal to probability of z less than 3 minus probability of what? Oh, wait, I'm coming. Wait, hold on. Remember, I told you that I can write this thing because there's no negative on our table. So I can say this is the same thing as probability of what? 1 less than z less than 3. Have you now?
Yes.
And to evaluate this thing, what do we have? This is the same thing as probability of z less than 3, then minus probability of z less than 1. Yeah, this will give you your answer. Okay, you see, in a nutshell, this is what you will do. Let me tell you what you are going to do. After you have changed this negative to something like this, then you just go ahead and find probability of z less than 1, probability of z less than 3. Then just subtract the two answers. That does it. Yeah, what's probability of z less than 1? That gives us 0.8413. What's probability of z less than 3? That gives us 0.9987 on our table. Yeah, if you check your table here, you will see. Yeah, this is 0.9987. This one was 0.8413. So what will be our final answer? So we now subtract it to 0.9987 minus 0.8413, and that gives 0.157. Exactly. Yeah, that is how it is. Okay, let me show you a graph, just like what I've explained before. You have something like this now. For example, you have something like this, and the one of 1, and you have one of 3. So remember, the one of less than 3, check. The one of less than 3 give you everything from here down here, and the one of less than 1 give you everything from here down here. Are we together?
Okay. Yes.
So the area between both of them is what? Remember, it will not work for you to subtract both of them. Then you now get this area that you have between them.
Yes.
Which means, see, take note that we don't subtract z values, but it's their probability value, the area that we subtract. Don't forget, okay? That's this area. Then this area minus this area. So like A2 minus A1, something like that. Okay, that's it. Let us pick another example and solve another example like this. Yeah, look at this one now. Look at this example, example 2. We have that we should find the probability of check minus 3 less than x less than 0.5. And you were given and your variance equal to 1. Okay. Yeah. Let's go. What do we do first? What do we do first?
So the first thing is that you need to change it to standard to get standard slope.
Exactly. So for s equal minus 3, your standard form is what? Don't forget x minus mu over standard deviation minus 3 minus 0 over. Remember, the variance is 1, standard deviation is also 1. So that's what minus 3. Also, you have this z equal x minus mu over standard deviation. So you have what the other is? This is 0.5, Avina.
Yes.
0.5 minus 0 all over 1. And that will give me what? 0.5.
5.5.
So do that with my probability. I'm coming. So what will I now write next now? Since I've standardized it, what will I say? I'll say my probability of what? Minus 3 less than x less than 0.5 is written as probability of what?
Minus 3 less than z less than 0.5.
Less than 0.5. So how will I write that?
So it can be written as probability of z less than 3. That probability of z less than 0.5 minus probability of z.
Okay, remember, now check. Both of them are not carrying minus now. So these are other cases. Yeah, the same way you are saying it is correct. Yeah, don't forget. When you have something like this, same that saying probability of what? Z less than 0.5
less than 0.5
minus probability of
z
less than what?
Less than
minus 3. Minus 3, yeah.
We did less than minus 3.
Yeah, don't forget this pattern here, what I did here. Same way. So is that minus we now go and get now, but no problem. First, let us find probability of z less than 0.5. Yeah, let's get that. Our table, what do we have? Oh, yeah, let's go to our table.
Yes. So probability of z less than 0.5 is 0.6915.
0.6915. 0.6915. And don't forget that I want to get probability of z less than minus 3. And don't forget I can say 1 minus probability of z less than 3. Have you know?
Yes.
Exactly. Yes. So let's go. Okay, so minus 3, yeah. 3, yeah, good. So let's go. 1 minus what probability of this? Less than 3. Let's go here and check it. 3 0.987. Have you know?
0.987. Yes.
Good. 0.9987. So you have 0.9987. So subtract these two, what do you get?
0.0.
So this is what we have. Hello, are you there?
0.00. Yes, I'm with you.
Yeah, 1 3. I mean,
yes, 0.0013. Yes.
So therefore, that probability that you want to get minus 3 less than z less than 0.5 will be equal to what? Yeah, all that you are going to subtract this to Abina.
Yes.
Yeah, when you subtract, what do you have?
You subtract since now we're going to have 0.6915 minus 0.0013. That will be 0.690.
Exactly. Yeah, correct. That's it. So that's it. Good. That's it. So as simple as so, all these are the tricky ones like this. So you can just master these two. All other ones will be simpler.
All right.
Okay, let us solve this question. So next question, question 3. Look at this question. They said data collected in an investigation of the breaking strength of a bamboo strands was evaluated to have a mean of 6 Newton per meter square. If the data is known to originate from a normal distribution with a standard deviation (2 Newton per meter square), what is the probability that the breaking strength of the bamboo strand selected at random will be A, between 5 Newton per meter square and 7 Newton per meter square, and B, 3 Newton per meter square, breaking strength 6.5. All right, so this is it. So let's solve this question. Are you there? Are you there? Hello?
Yes, I'm with you. I was talking. I didn't know I was in there.
Yeah. Let's go. So they said data collected in an investigation of the breaking strength of a bamboo strand was evaluated to have a mean of 6 Newton per meter square. So from the question, we have the mean to be equal to 6 Newton per meter square. And then they say it's known to originate, that is, that data obey normal distribution. So, and you have the standard deviation of 2 Newton per meter square. So what they now say, they say, what's the probability that the breaking strength of the bamboo selected around between this and this? That is probability. You have 5 less than x less than 7. Are we together?
Yes.
Like this is what you have to find. So this is what you have to find. Firstly, we standardize these values. So for x equal to 5,
that will be x minus.
That's 5 minus was 6, Sabina.
6 over 2. Yes.
Minus 0.5, Sabina.
Yes.
So for x equal to 7 Newton per meter square, what do we have? Z equals
7 minus 6.
7 minus over 2. What is 0.5, Sabina?
Yes.
So therefore, we are not asked to find, so the probability of us finding this guy, 5 less than x less than 7,
Listen.
is the probability of what? Minus 0.5 less than x 0.5.
Less than Z. Less than Z, sir.
No, Z, yeah, Z. Exactly, Z is correct. Yeah. So Z. So let's go. What we now do here is that check. This is like probability of me saying Z less than 0.5 minus probability of what? Z less than what? Minus 0.5. Abi now? Abi?
Yes.
Oh, yeah. How do we solve this one? Yeah. How do you find this one for me? Probability of Z less than 0.5. Let's take 0.5 here.
Yeah, that's 0.691.
6915. Yeah, 6915.
Yes.
0.6915. Now minus. Now look at this one. You remember what we have here? See, if I want to say the probability of Z less than minus 0.5, this thing that I'm saying what? Are we find
minus? Yes, I can find it.
I'm coming, wait. So, okay. Oh yeah, what do we have? What's another way to find it? Remember, I see how do I find this thing? 1 minus probability of what? Z less than 0.5.
Yes.
Yeah, so let's go. What do we have here? So 1 minus what's probability of Z less than 0.5? What's 0.5? 6912. I mean 6915. I mean
915. Yes.
So what do we have here?
Oh, now that's 0.3785.
That's 0.6915. I mean everything together.
Minus. No.
Okay,
0.6915.
Minus what do you have here?
Minus 0.3085.
So what would that give you?
So that would give me 0.383.
0. What?
383.
383. Have you done?
Yes, 383.
That's it. So that's the one between that. So the one between 3 and 6.5 also, you solve that in the same manner. So you are going to solve this classwork and just send your answer to me. Okay?
All right.
Yeah, that's just it. It's not
Send the statistical paper.
I should send it. I'll send it. No. Yeah, let me first. Yeah, I'll send that to you. No, I'll send to you.
All right.
So some second one, just send me your answer.